Hi there. For this video, we'll be solving absolute value equations. The basic cases on solving absolute value equations. So let us first understand how absolute values work. So for instance, if we have, say, a real number x and we get its absolute value, so the absolute value is represented by these two vertical lines. What this means is that we take the positive value of x. So we take the positive value of x. So for instance, if we have like 1 out here, then its absolute value is given by the positive value of 1, which is 1. If we have -2, its absolute value is given by 2. So that is how it works. So basically, whatever number is inside the absolute value, we take its positive. So with that in mind, we'll be tackling some basic cases involving equations on absolute values. So say if we have the absolute value of x is equal to y, and we start with the case where y is equal to a negative value. So let's say this one is, or let's just say that y is less than 0. So this implies that y is negative. So if we have x minus 3 is equal to -2, how do we determine the possible values of x that would satisfy this equation? Recall that a while ago, we say that if we have an absolute value here, say absolute value of 3, the outcome is 3. The absolute value of -3, the outcome is still 3. So, the right side of the equation must always be positive. But in this case, the right side of the equation is negative. So what does this mean? This means that whatever value of x we plug in here, the outcome cannot be -2. Since this is negative, and we know that the outcome of the absolute value is positive. Therefore, this case is impossible, or there are no values that will satisfy this equation. So we write this one as x is an element of the empty set. So there are no values that satisfies this equation. Let's have another example that is similar to that one. Let's have the absolute value of y cubed plus 2y squared plus y plus 2. And this one is equal to -5. Although this expression out here on the left looks complicated, again, recall that if we have a negative value on the right side of the equation, this one is impossible. Therefore, the possible values for y is none. So we say that y is an element of the empty set. So no values satisfy this equation. So that is the first case. So immediately when you see a negative value on this one, that immediately means that there are no values that can satisfy the absolute value equation. So pretty simple. Let's go on to our next case. Say if y is equal to 0. So for instance, if we have c plus 3 equals 0. So when will this equation hold? This equation will hold if this expression out here is equal to 0. Since the absolute value of 0 is simply 0. Since 0 doesn't have any positive or negative value. With this in mind, we know that c plus 3 must be equal to 0. What do we have here? We simply have a linear equation. So, applying our knowledge on linear equation, we simply move this to the right side to obtain c is equal to negative 3. And this one out here is the answer for this equation. Let's try this one. Let's have the absolute value of d squared minus 16 equals 0. So the same concept applies. For this equation to hold, this expression out here must be equal to 0. So we have d squared minus 16 equals 0. So we have a quadratic equation. Factoring the left side of the equation, we'll have d minus 4 times d plus 4 equals 0. So we have acquired this one since we have a difference of 2 squares. So 16 is just 4 squared. So for this quadratic equation to hold, either d minus 4 is equal to 0 or d plus 4 is equal to 0. So if d minus 4 is equal to 0, then we'll have d is equal to 4. If d plus 4 is equal to 0, then we'll have d is equal to negative 4. And these two are our answers for this equation. So basically, what we are doing is we are converting a absolute value equation to a known type of equation for us, which is the polynomial equations, specifically the linear and the quadratic equations. Also, you can verify that by plugging in these values in our original equation, the outcome must be 0. Let's have our last case. So far we had a negative value of y, a value of y which is 0. What's left is a positive value for y. So we'll have y is greater than 0. Or simply, what if y is positive? Let's go on to our example. Let's have 2z minus 5 equals 7. Now this one is not straightforward. You might initially observe that for this to be true, 2z minus 5 must be equal to 7. And that is indeed true. But there is another missing piece. 2z minus 5 can also be equal to negative 7. Since if we have the absolute value of negative 7, again we take the positive, so we'll have 7. So this still satisfies our equation. So we'll have two cases. Either 2z minus 5 is equal to positive 7 or negative 7. So we have case 1, the positive case. So we have 2z minus 5 is equal to 7. Solving this linear equation, we move this negative 5 to the right side to obtain 2z is equal to 7 plus 5 is 12. Then we divide to both sides to obtain z is equal to 6. Case 2. For case 2, we have 2z minus 5 is equal to negative 7. Moving the negative 5 to the right side again, we'll have this time 2z is equal to negative 7 plus 5 is negative 2. Divide to both sides, and we obtain z is equal to negative 1. Now, just to be sure, we can plug in these values back to our absolute value equation. So if we got z is equal to 6, then our absolute value will be 2 times 6 minus 5, and this will give us 12 minus 5, which is absolute value of 7, or simply 7. So this one is correct. How about for our second value of z? If z is equal to negative 1, then we'll have the absolute value of 2 times negative 1 minus 5. This one is equal to negative 2 minus 5, and negative 2 minus 5 is negative 7. The absolute value of negative 7 is 7. Therefore, z equals negative 1 is also a valid solution to our given. And so we have checked that the values of z that we got are indeed correct. So that is how we apply the absolute value, or answer the absolute value equation involving a positive number on the right side of the equation. Let's have one last example in this particular case. If we have n plus 3 over 2n minus 1, and this one is equal to 3. So again, 3 is a positive value. So we'll have two cases. So for case 1, we've got n plus 3 over 2n minus 1 is equal to 3. So observe that this one now is a rational equation. So we can apply some tricks that we know in rational equations. Particularly, we'll apply the cross multiplication method. So we can view 3 as 3 over 1, and applying the cross multiplication method, we'll obtain n plus 3 on the left side, and on the right side we have 3 times 2n minus 1. Simplifying, this one is n plus 3, and on the right side we have 6n minus 3. Then we can move n to the right side and move negative 3 to the left side to obtain 3 plus 3 is 6, and on the right side we have 6n minus n is 5n. Then we divide 5 both sides to finally obtain n is equal to 6 over 5. So that is our first possible solution to this one. We still have another case. Case 2. For case 2, we've got n plus 3 over 2n minus 1 is equal to the negative, which is negative 3. So applying the same concept, we can apply the cross multiplication out here to obtain n plus 3 is equal to negative 3 times 2n minus 1. Simplifying the right side of the equation, we'll have n plus 3, and this one is equal to negative 6n plus 3. Then we can move negative 6n to the left side and 3 to the right side to obtain n plus 6n will be 7n, and on the right side we have 3 minus 3, which is 0. or simply n is equal to 0. So to verify if these solutions are indeed correct, let's plug it in back to our equation. So at n equals 6 over 5, we have the absolute value of 6 over 5 plus 3 over 2 times 6 over 5 minus 1. So by some manipulation to remove this denominators out here, we can multiply 5 over 5 to this one. So this will be equal to the absolute value of 6 plus 3 times 5 is 15 over we have here 2 times 6, that will be 12, and minus 5. This simplifies to 21 over 7, or simply the absolute value of 3, which is 3. So it satisfies the given. Last one. If we have at n equals 0, then we'll have 0 plus 3 over, let's fix this one. 0 plus 3 over 2 times 0 minus 1, the absolute value of that one. So we'll have here on the numerator, we have 3, then 2 times 0 here will just cancel out. So we have here in the denominator negative 1. This one is equal to the absolute value of negative 3, or simply 3. So it satisfies our equation again. Therefore, we can conclude that these two values of n are the right values for this equation. And so those are the basic cases on absolute value equations. In the next videos, we'll probably be tackling harder absolute value equations, such as having, say, x plus 5 out here and a expression out here like x minus 2. So there are variables already. And then we'll probably also have two absolute values in one equation. So let's have like x plus 1 plus x plus 2, so on, like that. But before I end this, here are 3 exercises that you can work on to solidify your knowledge in this lesson. So we have exercises. So the first exercise, we've got z raised to 4 minus 4 equals negative 14. For the next one, we have x squared plus 2x plus 1 equals 0. And lastly, we have 2y minus 3 equals 9. So as you can observe, for the first exercise, this is the case wherein the right side of the equation is less than 0 or negative. This one is equal to 0, and this one last is greater than 0. So you can really work on the 3 cases that we had in this video. So that's it. Feel free to comment down below your answers and solutions to these exercises and your comments on the examples that we had in this video. So I hope you enjoyed this one, and that's all for this video.